In this lesson, we're going to learn how to graph quadratic inequalities. So it's the same as graphing our quadratic functions or equations. The only difference is since they're inequalities, we're going to have some shading that we do. So when I look at this one, I like to graph out of vertex form. So we're going to put all of these into vertex form before we graph them. To start, that tells me that I'm going to move my constant over. So I would have y plus 7 plus blank is greater than. And now this is gone, but notice I have a negative here. I can't have an a value that's not 1, positive 1. So I'm going to have to take this negative 1 out and divide both terms by negative 1. As I look for what goes in my blank, remember it's b over 2 squared, so 6 divided by 2 squared. Hopefully we see that that's 9. And remember, I've got to distribute that. So on my left side I'd have a negative 9 there. When I combine like terms on my left side, I have y minus 2 is greater than negative 1. And I'm going to go ahead and factor this. Factors of 9 when added together make 6 would be 3 and 3. So x plus 3 quantity squared. My last step then would be to add 2 to both sides. So I have y is greater than negative 1 times the quantity x plus 3 squared plus 2. When I'm looking for my vertex, I would say that it is hk, so negative 3, 2, and my a value is a negative 1. Now to graph this, I go to negative 3, 2, and then since my a value is negative 1, I would go down 1, right 1, down 3, right 1, down 1, left 1, down 3, left 1. I'm using this table here. If you don't have that memorized yet, you also could use your calculator. The tricky part now is that I have to actually not connect the dots until I decide if they should be solid or dashed. If you remember, greater than and less than symbols are dashed because those values don't actually aren't included in the answer. Greater than or equal to or less than or equal to is a solid line because those values are included in our answer. So because my problem has a greater than symbol, I'm going to make a dashed parabola. The last thing I do then is I need to shade where my values are. My problem says y is greater than. So I'm going to shade where y is going greater than, which would be this way. This is where y is going greater than. It's going to always be either the outside or the inside of your parabola. So in this case, that's everywhere on the outside of my parabola that I'm going to shade. You can do the best you can with your crayon or your pencil. And again, what this shading means, this means that if I pick any value in the purple area, see all these dots I'm picking? Any of those ordered pairs, if I substitute them into my original problem for x and y, it would give me a true statement. It is a solution to the problem. Anything not shaded would give me a false statement and is not a solution to the problem. So think of like when we did linear inequalities or linear programming, and we'd say the shaded part was where our answer was for word problems. Same idea here. Number 2, this one's a little different because I don't have a constant to move over right away, which is totally fine. So I'm going to go straight into the plus blank. So y plus blank is less than or equal to x squared plus 4x plus blank. Since I had a 1 here, I didn't have to factor anything out. My blank is b over 2 squared. So 4 over 2 squared, which hopefully we realize is 4. So I have y plus 4 is less than or equal to x plus 4x plus 4 squared, or factored, so it would be factors of 4 when added together make 4, x plus 2 quantity squared. So now I minus 4 from both sides, and I get y is less than or equal to x plus 2 quantity squared minus 4. So just like in the last one, when I get to this point, I'm going to try to name my vertex and my a value. So I'm going to look here and I'm going to say, okay, my vertex would be negative 2, negative 4, and my a value, since nothing's listed, is 1. There's a 1 in front of that parenthesis. I go to my graph. Negative 2, negative 4 is right here. My A is a positive 1, so I would go up 1, right 1, up 3, right 1, or up 1, left 1, up 3, left 1. Since my sign is a less than or equal to sign, that's going to be a solid line that I connect my parabola with. And then when I decide where to shade, I'm going to shade where my values are going less than y, which would be this area. So everything outside my parabola, again, this one happens to go up though, and these are all the solutions to my problem. Okay, number 3. I do have a constant now, so I'm going to go ahead and add 2 to both sides. So I have y plus 2 is greater than, and then notice I've got that 2 there again. So I have to factor that out. 2 times the quantity x squared minus 2x plus blank. So in my blank I have b over 2 squared. b is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. But remember, gotta distribute that there. So I take this, oops, I forgot my blank over there, didn't I? There's my plus 2, I can put it right below. So when I go ahead and add these, on the left side I'd have y plus 4 is greater than 2 times, and I factor. Factors of 1 when added together make negative 2, would be x minus 1 quantity squared. I finish by getting my y by itself. I subtract 4 from both sides. So my inequality in vertex form would be y is greater than 2 times the quantity x minus 1 quantity squared minus 4. My vertex then would be 1, negative 4, and my a value is 2. So I go to plot that. I go to 1, negative 4. Since my a value is a positive 2, I would go, remember we look at the chart here, I go up 2, right 1, up 6, right 1, up 2, left 1, up 6, left 1. This sign is a greater than sign, so I will do a dashed lines to connect my parabola. And it says y is greater than, so I'm going to shade where y is going greater than, which would be right here. That's inside my parabola. So for the first time, we have one that is inside. And remember, it's always going to be either all inside or all outside. Hopefully this is making sense for you. It's more practice completing the square, which is good for us, and then always good to get some graphing practice. Last one. I again move my constant over. So I have y plus 11 plus blank is less than or equal to. Notice I've got this negative 4 here, so I will factor that out. Negative 4 and then times the quantity x squared minus 4x plus blank. It's a minus 4 because it'd be 16 divided by negative 4. In my blank is b over 2 squared, so negative 4 divided by 2 squared, which would be negative 2 squared, which is a 4. Remember though, you got to multiply here, so this is actually going to be a negative 16 here. When I combine like terms on my left side, I have y minus 5 is less than or equal to negative 4, and then I find factors of 4 when added together make negative 4. So that'd be x minus 2 quantity squared. My last step would be to add 5 to both sides. So y is less than or equal to negative 4 times the quantity x minus 2 squared plus 5. My vertex would be 2, 5, and my a value for the first time is 4. We've never done that one before. So when I go to graph, I'm going to go to 2, 5, and I know my parabola, oh, excuse me, negative 4 is my vertex, or my a value, huh? My parabola goes down. I don't know though, look at this chart here, I don't have a 4 here. Now what could I do? I could graph it. You go on your graphing calculator, you punch this in, and you look at the table. I'm going to though try to use my math skills and say, what could this pattern be? Notice the pattern here. 1, 2, 3. So let's say, how about up 4, right 1? Would that be a safe estimate? Educated guess? And then up how many? Well, notice it's always timesing by 3. Whatever this 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3, so I'm going to say it's up 12, right 1. You plunge this in your calculator, see if that's right. You will see that it is. So I actually can use this table, and if I realize the pattern for any number they give me, I know it's going to be up that number, right 1, and then times it by 3, and right 1. So from here, I'm going to go down 4, right 1, and down 12, right 1. So 2, 4, 6, 8, 10, 12, right 1. Down 4, right 1, down 16, right 1. Now I still have to remember that I'm doing some dashed or solid lines here. This one happens to be solid, so I'm going to connect these dots, or pretend to connect them and not go through any of them. Wow, that is one pathetic looking parabola. As long as your parabola looks better than mine, you can't get that wrong on a test, because that thing looks pathetic. So now, less than or equal to, so remember, we are shading where it is less than or equal to. Look at that right there. I think that's inside, right? It looks like it is. It's a little bit off because I maybe was off on my connecting the dots, but it's for sure in. And remember, this is going to get wider, so it's inside here. If it was really close to the line and you weren't sure if you should pick it, pick a point that's not on the parabola, like let's say 0, 0, and plug it into the original problem, and it should make a false statement in our case, and then you know for sure if you shaded right. Hopefully that all made sense to you. If not, make sure you ask for help tomorrow.